In this video, we're going to take a look at the Model Mania Design Challenge from 2010. If you're unfamiliar with Model Mania, it's a design challenge held every year at SOLIDWORKS World where attendees are presented with a drawing like this and are tasked with creating the part in SOLIDWORKS both as quickly and as accurately as possible. Now, if that wasn't enough, when they're finished, they're given an additional drawing with a series of changes and additional tasks. In this video, we're going to look at how to create this part inside of SOLIDWORKS. It's a fairly simple part, and you'll notice that it's really comprised of two profiles. The front view, which contains all the information from the side, and the top view. We're going to look at how easy it can be to create this part, and then we'll look at the change. So let's dive into SOLIDWORKS. The easiest way to really tackle this is to start with everything that's in that front profile, though I am going to draw it on the right plane. This really doesn't matter in this case. I'm going to start by creating a decent amount of the geometry in this first sketch, starting with the bore at the front of the part, and then I'm just going to draw a circle for the outside there. I'm going to do the same thing for the smaller circle on the other side, typing in the diameter of the bore, but notice that I'm leaving the diameters of the other circles alone. And there's a reason for that. We'll look at it in a minute. I'm going to go ahead and connect these with a tangent line. Remember, in SOLIDWORKS, clicking and dragging off from a circle will capture the tangency and allow snapping to the other circle to be quite easy. I'm then just going to go ahead and trim the insides of these circles up. Now I'm going to go ahead and add those dimensions. And the reason I waited until now is notice that instead of a diameter value, because it's an arc, it's actually going to ask me for the radius, which is what I'm given on the drawing. I could have approached this by creating the diameters earlier and then changing it as well. Additionally, we'll specify the distance between the two centers here, which is 100 millimeters. Now you'll notice that the sketch is still got some blue geometry in it. This is because it's underdefined. Notice that when I click and drag this, that the circles aren't specified to be horizontal to one another. So I'm going to go ahead and use my control key, select those centers, and just choose to make those horizontal. Now I could include the keyway and the pocket at this point as well, but notice what happens when I do this. If I, for instance, created those 8 millimeter offsets right here, we'll go ahead and do that again on this case, you can see that the sketch starts to get really complicated. We've spoken in previous videos about including a lot of geometry in one sketch. I want to go back to keeping things simple in this case. So let's go ahead and just extrude this to 60 millimeter width, and I'm going to choose a mid-plane extrusion in this case. Now, we want to create that pocket still, and one of the ways we could do this is to, in fact, sketch and offset all that geometry. But the shell tool provides an alternative way to do this as well. When I use shell, I'll have to remember to select that back face and this front face, and when I press OK, SOLIDWORKS removes that material, leaving an 8 millimeter offset around those features. Then all I have to do is go ahead and add those fillets there. And in this case, I'm just going to select these edges through the geometry and specify the appropriate radius, which is 5 millimeters in this case. The fillet on the other side is a little bit more unique. We can create this using what's called a full round fillet. When you create a full round fillet, all you have to do is select the faces in order that you want the tangency to occur. So in this case, I'm going to select this top face on the inside. I'm going to right click to move to the next selection box in the property manager and then select the next face in the chain and repeat the process for the third face. Once you get to this point, you'll notice that there's a preview letting us know what it'll look like. Notice that this arc is tangent to all three of those faces, giving us exactly what we're looking for. Finally, while we're working on this side of the part, let's go ahead and look at creating that keyway. One of the ways I like to create keyways is just using simple rectangles from the middle of the part. In this case, we'll use a 3-point rectangle to capture the angle. Now the reason I like to do this is so that I can quickly throw a midpoint relationship onto this line. You'll see in a minute how that makes it easy to keep things centered. Let's add the width of this keyway. Now, when dimensioning lines at an angle, you'll notice a lot of times that your cursor jumps around to the 3 different types of dimensions you can create. If you know you want to create an align dimension in this case, remember, you can right mouse click to lock that in and notice it won't jump around. This makes it easy to then position the dimension exactly where you want it to be. For the offset distance, we'll dimension from the end of the keyway, and while holding the shift key, we'll dimension to the outside of that circle. Finally, we need to specify the angle, but notice before I do that how by adding that midpoint relationship, this keyway is always locked in to the middle of this circle. For the angle, I'm actually going to dimension to the front plane and then just choose one of the edges on this rectangle. It's 45 degrees. We'll then go ahead and simply choose to cut this through all in both directions. Now we've created all the geometry from the front profile. If we take a look at the top profile, there's a lot here as well. It's almost like two completely separate parts, but when we look over at the isometric view, we can really see how these come together. So let's look at drawing that shape on the top profile. Because this profile is very symmetric, I'm going to start by just drawing a center line and enabling something called dynamic mirror entities. When you choose this, you select a center line, which I have pre-selected, and hash marks appear at the end of that center line, letting us know that everything that I draw on one side of that center line will be duplicated on the other. Let's take a look. I'm going to start from this middle area and just draw a line out. Notice that every piece of geometry that I draw is actually duplicated over to the other side. Now this next line that I want to create, I want to ensure that it's parallel to this line. Notice by hovering over it, I get these little dotted lines that allow me to snap to that parallel relationship. That ensures that those lines will always be parallel to one another. And finally, when I close this off, because I'm drawing a line that would basically duplicate itself on the other side, SOLIDWORKS warns us of this, that it won't create that extra element. Then all we need to do is go ahead and start dimensioning this. Let's start at the bottom by adding that 14 millimeter dimension to the bottom. There's an 8 millimeter dimension up here at the top. We'll also want to specify the distance here as 8 millimeters as well. Keep in mind, you could have done that as an offset, though you'll have to have deselected select chain. Finally, we want to dimension from the center of this arc to these 2 points. Well, conveniently, we drew that center point right on our origin, so I can go ahead and just select this here and add the 35 millimeters and the 75 millimeter dimensions in this case. Once we add that last dimension, you can see that the sketch is fully defined. Now, once this is done, there's really a few ways you can approach finding that common area between these. The first is a little more complicated, but sometimes it's actually easier when the geometry is more complex. So I'm going to go ahead and show that in this case. This isn't the ideal situation you'd use this, but what I'm going to do is create an extrusion and choose not to merge the results. So now what I have are two separate solid bodies as seen in the Feature Manager tree. If you hold the Control key and select both of these, you can right-click and choose to create a Combine feature. Combine allows you to perform a series of Boolean operations where I can subtract geometry, one body from another, add the bodies together, or find the common areas as seen in the preview here. So that's one way we could have achieved this. I'm going to go ahead and undo to step back to this sketch. What I'm going to go ahead and do is instead create a cut. Well, you might be thinking, why would you create a cut? That's going to give you exactly opposite of what you need, which is what we see here. Within that cut extrude feature, there's an option called flip side to cut. And what this does is instead of cutting the sketched area, it cuts everything outside of that area. And in this case, gives us exactly what we're looking for. All that's left is to go ahead and add a few fillets. In this case, I'm going to go ahead, I want to add a few 10 millimeter fillets. I'm going to start by grabbing this edge, and you'll notice this pop-up. This pop-up's convenient when selecting edges to grab edges that are similar, and in this case we grabbed all the inside edges with just two selections, first grabbing the edge and then grabbing the appropriate icon. We'll go ahead and do the same thing for these outside fillets, which are slightly larger at 20 millimeters. I'm going to select the edge, and then I'll go ahead and toggle through the selections to get what I'm looking for. Same thing here. I'm going to go ahead and select this edge, grab the appropriate ones, and then just right-click to confirm that. Finally, there's a series of 2 millimeter fillets that need to be added throughout the entire part. We're going to go ahead and add those to the pocket here and the pocket on the outside right here. So we've got our part. It's for the most part completed. There is one other step on the drawing. If you look in the lower left-hand corner, they do specify a material. In SOLIDWORKS, we can do this by simply right-clicking on the material node and choosing the appropriate material from our favorites list, or if it's not on your favorites, going into material and choosing from the library that's available. And in this case, ANSI 1020 will not only apply the appropriate appearance and crosshatch, but also all the physical properties of that material as well. So not only does the part look different, if we go to evaluate, we can see that we get accurate mass properties. This is also going to be important once we move on to the next steps, where we're going to have to go ahead and perform a simulation. Speaking of, now that we finished the part, we would be given drawings for phase 2. When we look at the phase 2 drawing, we can see that there's a significant change to that sketch we created from the top profile. No longer is it a Y shape that's symmetric. Instead, there's only one branch coming out to the side. This can actually be a bit complicated, so we'll look at that. But also notice that we're required to perform a simulation on this part and get the results from that. So let's dive into SOLIDWORKS and look at how we'll make these changes to the part. All we really need to do, anything from the right-hand profile really hasn't changed. When we look at that, none of that geometry's changed. Everything we need to change happens in this cut extrude feature. So I'm just going to roll back and edit this sketch. What we need to do is we don't have any of these jogs taking place over here. But before I go about deleting geometry, let's turn on the visibility of our sketch relationship so that you can see what happened when we created the mirror. When we mirrored the geometry from one side to the other at every vertex, we created a symmetric relationship which maintains the symmetry across the center line. Keep that in mind as we go ahead and remove some of this geometry. In this case, I'm going to go ahead and remove this line here and this line here. But notice that I still can't drag this endpoint over, and that's because of the symmetric relationship to the endpoint on the other side. So in this case, I'm going to go ahead and delete that. Now I can drag this endpoint over to here. We also don't need this angled line in this case. But notice what's happening here. These two lines can't move because of these symmetric relationships here. Now you can do a few things to solve this. We can go ahead and use the trim tool and apply a corner trim, in which case I'll grab this line to this line here, and that'll go ahead and add that because these endpoints still stay locked in. But notice when I do this from this line to this line that this line turns blue. And the reason is the relationship that was locking this endpoint location in is no longer there. So the line doesn't actually know that it's vertical from when we created it. So we'll remedy this by just adding that vertical relationship in this case. Now when I go ahead and close the sketch, we can see that we have pretty close to what we needed, but all the fillets need to be updated. Let's see what happens when we roll forward. The first fillet has a warning on it. Notice this is because the edges that were over here are gone, and the elements that this intersection was created with have changed. So when we go to edit this feature, you'll notice that most of the edges are missing. All we're going to do is go ahead and reapply this fillet to a few of these edges here and here. Now, we could go through this dialog box and remove all these missing edges, but if you just press OK, SOLIDWORKS will actually do this for you. The same thing happens on the next fillet. Many of the edges that we had selected are no longer there. These edges on the outside over here and the ones that were on this side. In this case, all we have to do is press the OK button and let SOLIDWORKS remove them from the selection list for us. The last set of fillets will actually update perfectly the way we had them before. So we've gone ahead and made those changes. The last step we have to do here is to perform a simulation and find the factor of safety on this part. For this, I'm going to use Simulation Express found in every version of SOLIDWORKS. It's pretty easy to walk through this step-by-step process. I'm going to skip reading all this text and just go on to the first step in this process where we need to add a fixture. If you look at the drawing, this fixture is applied to this inside bore right here. So I'll go ahead and select that and press OK. At this point, we could add more fixtures, but none are needed, so I'll just simply press Next. Then we need to specify any forces we have. We want to apply the forces to these two faces, but notice the direction that that force is initially being applied in. It's directly out towards those faces. That's not what we want. We want to apply the force straight down. So we're going to choose Selected Direction, and for an entity to specify that direction, we're going to choose our top plane. Notice that the arrows have updated and they're pointing at the top plane, though in the wrong direction, so we'll choose to reverse the direction. Also notice that we need to apply 500 newtons of force to each one of those elements. So here you have the choice of choosing between per item or total force. We're going to choose per item in this case and press OK. So we've added our fixtures, added our forces. The next step would ask us to specify the material. But because we already defined this, notice that the information's automatically captured for us. So we can skip this step. The last thing we need to do is go ahead and run the simulation. This is pretty quick. SOLIDWORKS will quickly generate some results and let us know how the forces act on the part. Is this what we expected? If it is, we can simply say yes to continue forward and view these results. The results we get in Simulation Express are fairly simplified compared to SOLIDWORKS simulation, but we do get things such as factor of safety. In this case, it's 2.36047. You could probably just round that to 2.36. Likewise, if you wanted to see where the weak areas in your design are, you could update this preview to show us areas in our model where the factor of safety is below 3. And in this case, we can see that it's where this bend takes place right here. Additionally, if you wanted more information, you could get the maximum deflection which is asked for. So we can say show displacement. And here we get our maximum deflection, which is given in scientific notation. So we could just jot it down like that, 1.896 to the negative 0.001 if we wanted to. So we've gotten our results. So as you can see, the part was fairly simple to create, but the change was significant in this case. And in the end, we showed how we could use SOLIDWORKS Simulation Express to quickly analyze the results and see how strong our part is. To learn more about Model Mania and SOLIDWORKS World, please visit the links in the description of this video or on the blog post where it's hosted.